So today I'm going to do a presentation on AI-generated music and industry overview. The AI-generated music industry is rapidly evolving, driven by advancements in artificial intelligence and the growing demand for personalized music experiences. You're going to find that AI-generated music is all over the place without even realizing it. You're going to find it being used in advertising, in TV shows, in background music. Wouldn't be surprised if it's even used in some movies and other places that are a little bit more prominent. One, music creation. AI algorithms can create original melodies, harmonies, and rhythms mimicking human musical creativity. So what this means is everything that goes into AI, the AI is fed and trained on real human music, and in doing so, tears it all apart and through rule-based systems reassembles it into new creations. So AI is basically trained on everything human in order to replicate human creativity. What would be interesting from a composition standpoint, we're going to do that next, but I have often wondered what would happen if you took a copy of a copy or AI music and started to generate other AI music and then use that to feed into it. It'd end up with kind of a Xerox paradox where the outcome, there was a movie years ago called Multiplicity, and the original person copied himself twice, but then the clones ended up copying themselves, and the third one didn't turn out so good. So I've often wondered what would happen in that instance. So 2, music composition. AI can be used to compose entire pieces of music from simple jingles to complex symphonies. Now, in my case, I've actually taken full lyrics and turned them into songs through a system. So let's take a look at an example. And this time we're not going to use anything with lyrics. We're just going to do an instrumental, and we're going to type in, well, let's wait a minute on that. So we'll back up and say, 2, music composition. AI can be used to compose entire pieces of music from simple jingles AI can be used to compose entire pieces of music from simple jingles to complex symphonies. So in my case, I've gone through a couple examples in class, and if you go to my YouTube site, you can see I've generated multiple albums and several singles that are full songs with lyrics and a fictitious band. So there's a female lead that sounds just like a normal human would. It doesn't sound electronic. If you listen carefully enough, you can catch little flaws that do lend itself to, indicating that it may not be a real person. But you have to really listen to the song probably multiple times, or if you're used to working with AI systems, you may become more cognizant of it. Otherwise, if you're not paying that close of attention, you'd have no idea. 3, music arrangement. AI can help arrange and orchestrate music, adding instruments, effects, and dynamics to enhance the final output. So let's use an example. Here's my Suno account, and we're going to do an instrumental song, so there's going to be no lyrics, and we're just going to type in something very simple. We're going to say ambient music, piano, and for a title we'll say test piano. And when we hit the create button, it'll take a few seconds, and you'll see that it generates you'll see that it generates a thumbnail image along with the song, and then we can actually play the song. And you'll notice that it's a full piece. It doesn't say at the moment what the length of the song is going to be, but typically it's anywhere from 2.5 to 4 minutes in length. And depending on whether it goes over 4 minutes, like if it runs right up to the edge of 4 minutes and doesn't end like we would expect it to, we can extend the song and hope that it completes the next time. There's another music generating site that I use called Udio. I haven't used it as much lately, but one of the problems I would run into is that it would not end the songs very easily. For some reason, in some cases, I had a couple songs that I made that were 8 minutes in length because the song just would not end. But everything that was being generated was really good, so I kept that in and just kept rolling with it, basically. And we'll test out the next song a little bit, and you can tell, this is a very different song that it's generating. So that's an example of what you can do with the music generation. And then for music generation, AI can generate various music styles, including classical, jazz, rock, and electronic music, adapting to specific user preferences. So in my case, you can see with some of my examples here that this song, Shadows of Dunwich, I call out an epic female voice, funeral, doom, and gothic music, progressive metal, industrial metal, and new metal. And that is repeated through, and I was trying to get a song that I was happy with, and for the most part, the songs they produce reasonable results that let's put it this way. Sometimes you listen to a song and you're like, hey, that was okay, but then you'll hear something and go, that's the one that I'm looking for. So I'll start this one a little bit, and you can hear a few seconds of this particular song. And I really like the way that the song both had a good intro and ended up with the female vocals. Now sometimes I'll hear the song, I don't really care for the vocals, or sometimes I don't like the intro to the song, or it could be multiple things that are about it. But for the most part, it's rare that I get a song generated that I absolutely hate when it comes out. So age and size of the industry. In the early beginnings, initial research on AI-generated music began back in the 1950s with focus on basic music composition. So in the 1950s, there was something called the ILLIAC Suite by Lejeune Hiller and Leonard Isaacson. And it's often cited as the first computer-generated score. I have a link that I'll put down in the video description below, and you can check out the video of humans playing the first song. And in that video, you can hear the first AI-generated music composition that's played by humans. What ended up happening was the music was generated as a score, which it didn't have music output like what we just saw in the previous slide. The music that I was playing. So it had a long ways to go before it ended up being able to do this, and we'll talk about that further down in the age and size of the industry section. So emerging technology, advancements in AI and machine learning in the 2000s led to more sophisticated music generation techniques, particularly the Markov model. This was a statistical method for modeling systems where future states depended solely on the current state. And this led to deep learning, which revolutionized AI music generation in the 2010s, with the rise of AI-powered music platforms and tools. There were projects like Google's Magenta and Francois Pachet's Flow Machines, which produced a song called Daddy's Car. This was one of the first AI-assisted pop songs. And then with mainstream adoption, today AI-generated music is becoming increasingly mainstream with widespread use in various applications, which goes back to what I was showing in the Suno and the other suite, the Udio. Let's dive into key players in the field. Companies like Google, Microsoft, and Amazon, they're investing heavily in AI research and development, creating music generation tools and platforms. So before I did this project, there were a couple tools that I came across, AIVA or AVA, Amper Music, and Boomi. These three I had not heard of before. I've been using Suno and Udio in the past to make my own music. So the tech giants are making stuff. I know that a lot of their work with MuseNet and Google's Music Transformer, a lot of that stuff is built into a lot of the music generation stuff. So even though we may not be using their brand name tools that are like, maybe on one of their, I don't know if there's a Google Music, app per se, but a lot of the tools and libraries that they've developed tend to be wrapped into some of the music platform themselves. Startups. Numerous startups are focusing on specific aspects of AI-generated music, such as personalized soundtracks, music composition, and AI-driven music production. So there's a few different things that are happening here. When you look at something like Suno, for example, so since there are specific aspects of the music composition in Suno, we'll pull Suno back up. In the dashboard for creating a song, you have a section for the lyrics where you can enter in your own lyrics, or you can write about something that you want it to talk about. I've not really tested out having it write me lyrics for something. I'd rather, I've gone outside of the platform and worked separately to generate lyrics that I want. For backstory on the first two albums that I wrote or that I produced, I took a letter that I had written many years ago, and you might be able to find this in one of my previous videos where I talked about this a little bit. Not for this class, but for something else, where I had taken a letter that I wrote to someone, but I never gave it to them. And I ended up having AI read the letter, scan through it, and to extract multiple songs out of it. I think I got about 5 or 6 songs just from a letter that I'd written to someone. And that ended up spawning kind of a spin-off into other things, and that's how I ended up with 5 albums in total. Was I was able to expand on one thing that had a lot of personal history, kind of dumped a little bit of my soul out into it, and it started to evolve into things that had been going on in my life over the last 30 years. I end up usually putting in my own lyrics, and you can add, several things. Let's take, so in the prompt, in the lyrics, you can actually take and write in you want an intro and how many bars you want that to be. You can leave the bars out, or you can leave it in, or whatever. Then you say, okay, verse 1, you have your lyrics, and you have your pre-chorus, your chorus. You can put in an interlude if you want. You go into the next verse. It's very customizable. And then you have your bridge. Go back through. You can add more chorus. You can have guitar solos, and your outro, and then the song hopefully ends. Sometimes it doesn't, and you can extend the song with one of these buttons, which ends up kicking out, somewhere between a typically 3-minute and 4.5-minute, 5-minute song. I've got a couple that are a little shorter than that, a little bit longer, but typically that's where it ends up falling. And you have your traditional music industry. Established record labels, music publishers, and artists are embracing AI tools to enhance their creative processes and reach wider audiences. So, for example, we have some AI tools that we can use in order to enhance music. This is pretty cool. I'm going to take a song that I'm actually not going to I'm not going to publish this song, but I'm going to use this as an example of how AI is mastering the music. It's using algorithms to enhance the song. You can actually do an A/B test against the mastered version versus the original version, and it's graphically very interesting in how different often the results are. So let's take a look. Right now it's preparing the preview. It's almost done. Okay, so graphically you can see we have the original. You can take the intensity. Usually what I end up doing is I make it high, a little bit brighter. It depends on the type of music that you're generating, but you can actually see visually what the algorithm is doing to the music in the mastering process. So if we hit the play button, you can hear it this way, and then the dramatic difference in how the song sounds between these two. And then when you're done, you can download the master track, which I'm not going to do because that ends up putting it in the list, and I don't really want to do that. And that's just one example of like how awesome these tools are to enhance the creative process. There are probably way more tools. I noticed in one of my other apps that I use for editing the music, or editing music files and any video file, including this one. There are now AI tools embedded into the software. I haven't even used those yet. I'm not even sure if they're free to use or not, but you'll start to see that stuff. I noticed that AI is now used in Adobe Reader. So if you're opening a PDF, it has a tool up there. So AI is starting to infiltrate into everything, and I hate to say it, but I mean, it's about time, because this stuff's been around for quite a while, but it's just finally making its way to the marketplace. So just imagine, if they have this in the marketplace and it's being launched to us, imagine how advanced some of this stuff must be behind the scenes that are still in the development stage, that just haven't made their way to market yet. So let's take a look at the customer demographics and the use cases. So we have musicians. AI tools are assisting musicians in their composition, arrangement, production, and they're offering new creative possibilities. And I gave an example with my own music. Another demographic would be gamers. AI-generated soundtracks create immersive gaming experiences, enhancing the player's engagement and immersion. So you can imagine where an indie a game development company may have struggled to go out and get someone, an artist or a serious composer to sign on to something. They can go to an AI generated soundtrack, and instead of having to wait months or years for something to be developed and sound professional, they can actually do it themselves in a matter of hours. Have an entire library of music that they can use and polish it the way that they want. So this is a huge game changer, and I imagine that gamers have been using this for quite a while, and if they're not, they're probably losing out in market share, and the amount of time and profitability to get their stuff out there. Filmmakers are another demographic. AI-generated music helps filmmakers score their projects with custom soundtracks tailored to specific scenes and moods. So it may not make sense for someone that's making a Star Wars movie to not use John Williams music, but there could be a very good case, like if you have the something like the Halo series. I just watched it recently. Now, I imagine that their music was probably all composed, and I think it was one of the most expensive shows out there. Lord of the Rings, I think, is another one, or The Rings of Power, excuse me, is another show that has a massive budget. So they're probably, paying someone to actually make the music and perform it live, in the recording studio. AI-generated music is going to help small-time filmmakers, indie makers, much like what we discussed with the gamers, that they may not have the resources to generate this stuff with a live, you know, musicians or a large studio. So this is a very good option for filmmakers. And then content creators are another demographic where AI generated music, provides royalty-free background music for videos, podcasts, and other content, saving time and resources. Now, this is very interesting because, like with my experience on YouTube, I'm not monetized yet. I haven't grown large enough. But any music that you put into, say, a YouTube video, if it has a copyright strike, you can't earn anything on that video. So YouTube content creators should be very meticulous in what they put into their videos, because any strike against them will cause that video to not be monetized, and it can actually be monetized to the original person. So let's say that I make a video, an hour-long video, and I have 3 minutes where a song by Ozzy Osbourne or somebody is playing in the background. And let's say I didn't even play it in its full capacity, but there's a copyright strike that happens against my video. Well, if anybody watches my video, that anybody that watches it, that view time ends up going to Ozzy. That's how, on one hand, it's very messed up. I understand the logic behind the copyright strike and how that can, send the funds back to, like if I took the whole song and I stuck it, up, and tried to monetize it for myself, I could see why that should go to, the musician. But if you have a song that's playing in the background, and let's say somebody walks by and, they've got their earbuds blaring and the microphone picks up on that. Well, if YouTube picks up on the background music because of somebody's earbuds, that could, potentially be an issue. And I think we'll talk about that a little bit later in one of my upcoming slides. But I don't want to get too off the rails here. But content creators have to be very careful with using any sort of music that has the potential for being a copyright strike. So having AI-generated music is a huge boon for people that are creating their own content. So current changes and risks in the industry. We have increased automation. AI-driven automation is changing the music industry landscape, potentially displacing some human roles. So like I had said, if you have a small indie group and they're using AI to generate music, that means that someone that could have been playing the music live in a studio may end up being displaced. That is a risk. However, the converse side of that is if the game or whatever was never going to be made in the first place, then that person might have never had the opportunity anyway. So there's two sides to, it's a debatable issue. Copyright concerns. The ownership and copyright of AI-generated music raises ethical and legal questions requiring clear guidelines. What this means is you have the AI has to be trained on something, and a lot of times it's scraping the internet, YouTube, whatever, and using somebody else's music in order to train its model. And if those artists aren't using or giving their if they're not giving their permission out from the outset, that does raise the issue of, is this a legal or ethical problem that we're running into? However, if you're on the other side of it and you say, okay, I take a robot, I build them from scratch, I stick them in front of a radio, and the stuff is being played for, the robot's there listening to the radio for, a year, and they listen to all kinds of music, and then you say, hey, robot, play me a song, write me a song and play it, that you're inspired from. Would that be a problem? there's an argument to be made. It'd be like, okay, if you go to any Wikipedia site or any Wikipedia page about a band, and you read through their biography and influence and stuff, a lot of times they'll say, okay, I'm going to make this up because I don't know off the top of my head. I'm going to say, okay, Seether was influenced by Ozzy Osbourne, Black Sabbath, and Metallica, or something like that. I'm probably way off, but what that means is they listened to all that music when they were growing up, and they were like, oh, I'm going to write my own music, and I'm going to use their style to influence my own. Should that be considered something that, they owe those original bands for? That's where the gray line, is that those people listen to something else, and everything is meta to another thing, and it's building upon it. So is AI stealing something? I don't think so. The AI has to learn from something. Humans have to learn from something. So in my case, I kind of lean towards, I think unless there's a huge likeness of something that I don't know. I don't think that I don't think it's the issue that the record labels are going to make it out, because I know that they're trying to sue Suno and Udio, the two tools that I tend to use. And then ethical considerations. The use of AI in music raises ethical concerns about authenticity, creative control, and potential bias in the algorithms. So what this, can lean towards is, if you're looking at, say you put in a prompt and you say, I want to have something, well, there's a few different things. Let's say that you type in, I want this to sound like Alanis Morissette, and the system kicks out a song with Alanis Morissette's voice. It sounds like her band and everything. That's a bias in the algorithm, that it is borrowing something very specific without the permission of and no creative control over the person, that's that influenced the training of the model. However, another aspect of bias in the algorithm is, let's say that the model was trained on 98% hip hop and 2% metal, and you don't know that, and you go in and you say, I want a metal song, and the goth music, the doom metal and whatnot, and it spits something out, and you go, what is this? The bias in there is not giving you what you want based off of its training models. Or you can say, country music, if the models excluded completely country music, and you type in, I want, whatever. I don't listen to country music, so this is probably a bad example for me, but if I was to say something like whatever Garth Brooks or Alan Jackson or whatever, one of those guys are, and you type in their type of subgenre of bluegrass or something, and it doesn't kick anything out, or it gives you something that's awful, that's a bias in the algorithm because it wasn't trained in it. Or the prompting is not set up properly. So there should be some transparency in how those algorithms are set up in order to get something that anybody can use to make anything. So with the regulatory landscape, copyright laws, the legal status of AI-generated music under existing copyright laws is being debated. So we talked about several of the issues with strikes, with the ethical concerns, and some of the issues like the record labels, or RIAA, suing Suno and Udio, over what's being used as training material. Privacy concerns. Data privacy regulations are relevant to the AI music platforms that collect user data to personalize music recommendations. So if I go into Suno or Udio and I put in a bunch of personal information, and I'm making a whole bunch of music and stuff, what's to say that they're not using all of my preferences, my name, my billing information, and they're putting it in a nice, neat little database, and then something happens, they get hacked, and suddenly uh, a whole bunch of information about my tastes and stuff are in there. Now, let's say that I'll use a hypothetical situation. Let's say that I am a deacon in my church, and uh, I have, a large body of, people that come to my parish or something, and I have a reputation, and whatnot that I'm trying to protect. And and at home, I'm making death metal music. There's probably a concern to be had that if I had death metal music and very dark lyrics, and my personal information gets out there, it could destroy my personal life. So that's a privacy concern that anybody should think about. And then we have fair use, determining the boundaries of fair use in the AI generated music. It's crucial for ensuring its ethical and legal use. So this goes back to what I was saying about all of the training material that goes into the AI generated music and its algorithm. Is it okay to scrape all of that information in order to train the algorithm with everything that it uses to generate music? Again, I go back to the radio issue. Is all of that stuff is broadcast on the radio, and what's the difference between a robot sitting in front of the radio versus a human sitting in front of the radio, and both writing music at the same time? One just happens to do it a lot faster. So obviously you can see what my opinion is on that. So in conclusion, the industry's potential and challenges. We have growth potential. AI generated music has a potential for revolutionizing music industry, expanding creative possibilities, and reaching wider audiences. This is, if you look at the S curve on this, it's in the exponential growth upward trajectory, and it's I think there's quite a ways to go before it plateaus out. There are regulatory challenges. Clear regulations and guidelines are needed to address ethical and legal concerns surrounding AI-generated music. So, we covered a lot of the fair use issues. What are the training models? What are the biases? Are there any, ethical and legal concerns? This is new territory. And the issue legally is that it's changing so fast that I don't think the legal system is going to be able to catch up with it anytime soon. So buckle your seatbelts and hang on, because if you're in this industry, you are probably going light speed and trying to stay ahead of it. And then you have the future. The future of AI-generated music holds immense promise, but it will be shaped by ongoing advancements, regulations, and societal acceptance. So we haven't really talked about the societal acceptance part of it. One thing that if it doesn't continue to develop and iron out some of its bugs that it has, like I'd mentioned, that if you listen to something long enough, frequently enough, and pay attention close enough, you can hear the flaws that are in there. One of the things that I find that I get a little annoyed about with some of the music that I generate is when I'm listening to the music over and over to determine whether or not I like the song enough to move forward with it, is I'll find a flaw in it, and I'll try to determine whether it's a make or break issue. And there is a song that I have, I don't remember the name of it off the top of my head, but towards the end of it, there's a part where the singer, the artificial singer, is singing a note. They hit a high note, and the high note sustains, and it keeps playing, but then she starts singing again normally while the high note is still playing. Most people probably never notice that, but I've listened to the song enough times that it bothers me, because it's not possible. It's not humanly possible to do such a thing without having two people. So I think that the system, that the algorithms and stuff need to have a little bit more control over things like that, or else if enough music ends up becoming mainstream, that more people are going to be like, hey, wait a minute, this is fake, this isn't real, they need to fix this. Right now, I think a lot of people are kind of glazing over it because it is new and it is really awesome and it can create some amazing things. But with anything, you start to pick it apart. You start to find flaws in it, and I think an interesting analogy to this would be like the Bee Gees back in the 70s and 80s were huge. Everybody listened to the Bee Gees. Some people in the class may have no idea who they are, but I think one of their songs, the "Staying Alive" song, that was huge. It got to a point where they were so popular that the public opinion of them flipped on a dime, and people went to a stadium, they took all their CDs and they burned them and had a huge fire burning their stuff, and the Bee Gees disappeared. Now, the individual people ended up going into other things. One guy became a famous producer, so they had their 15 minutes of fame, but it goes to show that with any good thing, it can run out really fast, and there is a potential for this to actually flip over and turn the society off completely. So I think that's something that needs to be considered from a societal acceptance standpoint. Now I'd like to shift gears a little bit and go into emerging technologies and do a comparative analysis. So this section of the presentation is exploring the landscape of emerging technologies, comparing AI-generated music, which we talked about earlier in the introduction section, with augmented reality or AR, quantum computing, blockchain, and advanced NLP or natural language processing. We'll dive into their potential, their limitations, and future directions. AI-generated music uses algorithms to compose and produce music. On the other hand, augmented reality overlays digital information onto the real world. So if you've ever played a game such as Pokemon Go, you take your phone, you wander around, you look at the whatever's in front of you, and it'll put a digital character on your screen in place of the spot that you're looking at. So let's say hypothetically you're pointing your phone at your chair, and Pokemon character is sitting there in the chair. That's what AR essentially is. Quantum computing leverages quantum mechanics for high-speed computation. And we'll go into blockchain and advanced NLP in a separate slide. But when we look at AI-generated music is rapidly evolving, with the algorithms able to compose and produce the unique musical pieces in various styles. So we talked about that again earlier in this presentation. AR enhances real-world experiences with digital information, creating interactive and immersive environments for entertainment, education, and beyond. So you can kind of think of AR as, instead of virtual reality where you're putting on a headset and looking at something that isn't actually in front of you, augmented reality is kind of the inverse of that, where you're taking what reality you have and you're imposing some sort of image onto that, like we used the Pokemon example. Now, quantum computing tackles complex problems by leveraging the principles of quantum mechanics, enabling advancements in fields like drug discovery and material science. In this case, you're using, instead of just zeros and ones for doing binary code, in this case, they're actually using probabilities in order to do computing. It's a wild technology that has an extreme amount of promise in the amount of computing power that can take place. So it's a remarkable technology that it basically has the capability of a lot of our current encryption methods aren't able to be processed in an efficient period of time with the computing power that we currently have. But with quantum computing, a lot of our encryption processes or standards are going to be blown out the window with this. That's how powerful quantum computing will be. So if we look at blockchain, blockchain facilitates secure and transparent music distribution, enabling direct artist-to-fan connections and royalty management. So this is, if you're looking at it from a music standpoint, blockchain Anytime you talk about Bitcoin or Ethereum or any of the cryptocurrencies, these are basically transactions that are put into a digital ledger that stack on top of each other. So at any point, any transaction that takes place, it's being recorded somewhere that can be referred to, and audited basically for future tracking purposes. Now, what this means for a music standpoint is you could actually have, a very distinct ledger for the distribution of the music. You can also very easily track the rights to stuff, whether it's from the musician side or from the listener standpoint, that they buy something and they transfer it from one device to another. Without having to go through, oh, I have my Apple iTunes and I've already authorized, my 5 devices or whatever. This way, in blockchain, you could use that to say, well, I went from my iPhone to Android and I don't have to, pay any extra fees for it because I own that license to the music that I purchased. And then if we look at advanced NLP enables AI systems to understand and generate music based on natural language descriptions, allowing for greater control over artistic expression. So what this does is it allows a more dynamic ability to take in input from the user or the person that wants to generate something. Like, in my case, if I'm wanting to create some lyrics for a particular type of song. In older versions of NLP, I would have got something that seemed very blocky, very rigid, not very human sounding. But as the advanced NLP starts to emerge from this, you're going to find that because it's something that can kind of learn on the fly, or it gets updated more frequently and has a lot more computing power behind it, it'll be able to start sounding more natural, more human. It'll be able to, instead of using a lot of repetition, which that can also be a problem when generating music lyrics, from song to song or even within a song, within the same song, that the NLP, the advanced NLP, will be able to, look at, what is it generated before, what's it need to do at this moment, and maybe even forecast, well, I've got these other things that I have to write, and I'll try to make sure that, looking forward in the tasks that I have in hand, so that it doesn't have redundancy built into the output, I mean. When we look at the risks and challenges overview for AI-generated music, AR, quantum computing, blockchain, and advanced NLP, there are some risks and challenges that do tend to overlap. Now, we've talked a little bit about some of the risks earlier on in the introduction section of this, but when we look at AI-generated music versus AR, there's some shared risks such as privacy concerns, any data collection for personalization, potential for technology addiction. This is something where, your brain is like getting all these dopamine hits, and, it causes someone to, want more and more. We see, these kind of behaviors, whether it be, gambling addiction, adult entertainment type of addictions, things of this sort, where the brain is seeking more and more dopamine. And when we look at something that's unique to AR, physical safety issues, some sort of distraction in real world environments, let's say that there's a Pokemon on the train tracks and the person gets so wrapped up in whatever they're doing that they don't avoid the train that's, potentially coming their way. Or higher hardware requirements and costs. These are things that are kind of unique to augmented reality. So when we look at the AI generated music versus quantum computing, there are some shared risks, such as the potential for widening technological inequality. So what this means is there's a few different aspects of this. You can look at high development and implementation costs. Quantum computers are extremely expensive to build, maintain, and this limits access to wealthy nations and large corporations, as the sole players in the field. There's very highly specialized knowledge requirements, so operating a quantum computer requires highly specialized skills, creating a really high knowledge gap. I mean, there's only a handful of people relative in the industry that are actually one, researching this, and B, building these things, and then C, actually trying to use whatever's been being developed so far. So this is something that not everyone has access to. And then from an infrastructure need, quantum computers need very specific environmental conditions, and this further limits where they can be deployed. Now, what's unique to the quantum computing, you have a threat to current encryption methods, which we mentioned a little bit earlier. You have extremely high development costs, which we just mentioned a moment ago, and complexity in the programming and use, since it's not widely used. It's so early in the development stage. So when we move on to AI generated music versus blockchain, a couple of the shared risks involved here. You have some regulatory uncertainties. We talked a little bit about how AI generated music is fighting in the courts right now, and there's very little regulations. There's very little protections from a copyright standpoint. And then you have the potential for disrupting established industry models, which again, the RIAA is not real happy right now. They're trying to sue the pants off of Suno, Udio, and I'm not sure if there's a couple other lawsuits, but I know that those are the two main ones that I'm aware of. I actually just heard of another AI-generated music suite today. I haven't looked into it yet, but from the overview that I saw, I'm very interested in it. So I'm going to have to dive into that one. It looks like it has a lot more front to back integration, whereas I'm doing everything piecemeal. So I'm looking forward to looking at this. Now, what's unique to blockchain? There's a high energy consumption concern. I think it was El Salvador built some of their mining, Bitcoin mining system around geothermal or volcano for free energy in order to mine on the blockchain. So there are ways to kind of work around it, but if you have just someone that's out in the middle of Kansas or something, and there isn't a lot of access to geothermal or solar. There might be some access to solar, but you need a lot of land for that. That it means that you're basically pulling off the grid, and that can be very expensive, and can also have some environmental effects. Now, scalability issues with blockchain, as like in Bitcoin's case, as more Bitcoin is mined, the amount that's available, they call it the halving. I think it's called the halving. But anyway, periodically, the amount that is doled out as a reward is split in half. So it makes it more expensive and more difficult for people to just dive in and be profitable. In the beginning, when anybody could do it with a computer, the rewards were a lot higher from how much Bitcoin do you get, but the Bitcoin wasn't worth a whole lot. Well, now that Bitcoin's worth a lot, everybody that has high computing power is in there, and it's too difficult for the average user to get involved without having to buy a very expensive rig or rent one. I guess you can also rent, but that creates its own issues as well. And then complexity for average users. It's not as difficult to mine as it used to be. I've actually dabbled in it a little bit. I was able to, with relative ease, mine something called Ravencoin. But it's not something that if someone is not tech savvy at all, they will have some difficulty with this. And then AI-generated music versus advanced NLP. So we talked about this a little bit, especially with actually both of the shared risks, the bias and the AI models. We talked about that earlier in the introductory part with different music types and what can be generated or not generated based on the bias. And then data privacy concerns are very similar between the two. Now, what's unique to advanced NLP is you do have the potential for misinformation to spread. So, if you have something that is being trained and it's being trained on bad data, or if it's something that it learns on the fly with data input, like let's say you have 1,000 users or 10,000 users, that the model is learning how to interact with people, but it's based off of the way that the users are speaking and it's not factual. If that has any way of leaking into the training model, that can cause very easily like a chat bot, for example, to start behaving poorly. And then you have cultural and linguistic biases in global applications. So if you imagine a phrase that is used in English, I'm trying to think of one off the top of my head, off the top of my head. We use that kind of a phrase all the time without really thinking what it literally means. But if you try to say something like that in another language, they're going to look at you kind of funny. So there are different things to consider when it comes to cultural and linguistic things. Years ago, I'd taken some classes in marketing, and they had talked about how there are certain no-nos in depending on what culture you're dealing with. Like you never shake with the left hand in certain countries because that's offensive, and you don't wear green in other countries because of whatever historical issue. Like there's a whole bunch of things that what seems normal to us in the United States can be very offensive in another country or another culture. Now, with the transformation of human-computer interaction, advanced NLP enables more natural and intuitive interactions with computers, opening new possibilities for personalized experiences and seamless communication. So what this means is, for an example, when a user tries to communicate with their device, they don't have to use any special language or certain commands. An example that I can think of off the top of my head is Unix. If you're not very familiar, if you've worked in Windows and you're not very familiar with Unix, it's a whole different system, and it can be very overwhelming to a new user. On the other hand, some other examples of ways that we will communicate with devices. We have voice assistants now like Siri, Alexa, Google Assistant, and there's various chat bots for customer service. You can basically think of this as your Jarvis to Tony Stark. And advanced NLP has the ability for automation of text-based tasks. NLP technologies are automating various text-based tasks such as content creation, customer service, and document analysis, leading to increased efficiency and productivity. So AI can generate human-like text for various purposes, from news articles to creative writing. This impacts fields like journalism, content marketing, and even creative industries. I was talking to someone recently at work, and we were looking at a visual aid that was out in the break room, and they were looking at the visual aid in order to get some ideas about some marketing that they were doing for social media. And this is something where ChatGPT or Claude or some of the NLPs out there can work with a user to bounce ideas back and forth. And it's surprising sometimes, even with when I'm working with ChatGPT or Claude with lyrics, that I'll put something in, I'll think of one direction that I want to go, and it'll sometimes give me something that's I don't want to say in the complete opposite direction, but it goes in a different direction. Sometimes I like what it did, sometimes I don't, but there's a lot of times where the interaction between you and the computer, because it can draw on so many resources, it gives you access to a lot more information. It's almost like in some cases you're dealing with 1,000 people, or someone that has the knowledge of 1,000 people all in one interface, rather than having to work with an entire organization or an agency to get the same results. So this is very transformative in the industry. So looking at the summary of the main points, the comparison highlights the distinct potential and challenges of each of these emerging technologies. So with AI-generated music, this is a very rapidly advancing, potentially revolutionizing music creation, for music creation and experiences. Augmented reality, we're experiencing widespread adoption in various fields, enhancing real-world experiences such as, gaming. We've seen some devices that, in some cases, they're, like Google Glass. It came and it went, but there are other things that augmented reality is starting to be, pick up speed and, be used in, training or gaming applications. Quantum computing, it's still in its very early stages, but it holds a significant promise for the scientific and technological advancements. Again, we looked at what it means for encryption as both a benefit and a risk. Probably more for us a risk than the people that are developing it. But that's the main point that we drove there. And when we look at blockchain, can secure and track ownership of the AI-generated music, fostering a fair and transparent music market. And then if we look at AI-generated music and blockchain together, blockchain can secure and track ownership of AI-generated music, fostering a fair and transparent music market. When we look at AI-generated music with regard to advanced NLP, NLP enables users to describe their desired music style in natural language, leading to AI-generated music tailored to specific preferences. And then when we look at the interactions between blockchain and advanced NLP can enhance blockchain security and transparency by automating complex interactions and providing user-friendly interfaces. So in conclusion, the emerging technologies that we discussed in this section, they're shaping the future of music, entertainment, science, and beyond. Innovation, these technologies continue to evolve and bring new possibilities and challenges, some of them more in the near future, and some several years out, or maybe over a decade to go. And then we have collaboration between researchers, artists, industry leaders, many stakeholders that have to work together. This is crucial to realize the full potential of these technologies. And then when we look at the future, the future holds exciting possibilities for the intersection of these technologies. They're shaping the way that we create, experience, and interact with the world.